Okay, imagine seeing this video. It's just this massive cloud of ice, rock, dust just exploding upwards from a valley in the Swiss Alps.
It was terrifyingly real, though, that was the scene from Blatten, a village there in Switzerland's Valais region.
Right.
It happened right after the Birch Glacier, high up above it, just suddenly catastrophically collapsed. A huge force of nature.
And we've got some really interesting sources to dig into today to try and understand this. We're looking at an NPR article, which gives us that kind of ground level view, the human story. And we also have analysis from a geophysicist from a YouTube video transcript, really getting into the mechanics, the why behind it, and maybe what comes next.
Yeah. So our mission today is basically to pull out the key stuff from these sources, figure out what exactly happened, why this event was so, extraordinary, and what these powerful forces might tell us about the future for places like this.
Sounds good. Let's get started. So first, let's set the scene. Where exactly is Blatten, and what did the sources say happened there on that Wednesday?
Okay, so Blatten, it's a small village kind of tucked away in a valley in the Swiss Alps. It's in the Valais region.
Okay.
If you're picturing southern Switzerland, it's down there. It sits below this really impressive mountain, the Beechhorn, north of Italy, south of Bern, the capital.
Right.
And on Wednesday, May 29th, 2025, that valley just became the site of this huge disaster.
Because the mountain above it essentially just gave way.
Pretty much, yeah. Almost the entire Birch Glacier collapsed. And it brought down this colossal amount of rock and debris with it. The impact, devastating.
Yeah.
The sources, they use really stark language. Blatten was largely wiped out. The landslide destroyed everything in its path. One source said the debris basically covered the entire village.
Wow.
Another even suggested it was wiped off the map, though, some buildings probably still remain, just buried or damaged. The damage everywhere is described as considerable.
And it wasn't just the buildings being crushed, right? The landscape itself changed immediately in a dangerous way.
It really did. All that material, rock and ice, rushing down, blocked the local river, the Lanza.
No.
And that blockage just caused water to back up instantly, forming a lake that then started flooding whatever buildings weren't already buried. And the sources really highlight a big concern there. If that built-up water overflows onto all that loose debris, well, they use the phrase torrential lava flow.
Lava flow, like molten rock.
Ooh, no, not actual lava,
Oh.
but imagine a supercharged mudslide. Just a really fast-moving, incredibly destructive mix of water, ice, rock, mud, just surging down the valley.
Right, okay, that makes sense.
Wow.
Okay, let's talk about the scale of this collapse, because the numbers I saw were just mind-boggling. This wasn't just like a chunk of ice falling off.
Not even close. The sources quantify this, and it's pretty staggering. Before the collapse, the glacier itself was supporting something like 9 million tons of material.
9 million tons. It's hard to even picture that.
It really is.
Yeah.
And then when it finally let go, 3 million cubic meters, that's nearly 4 million cubic yards of rock and debris that had built up on the glacier came down with it.
Just immense.
Yeah. And the deposit, the stuff now sitting in the valley, that's reported to be several dozens of yards thick, stretching for about a mile. It's just this huge scar on the landscape now.
But here's the really incredible part. Maybe despite that unbelievable scale of destruction, the human impact was, thankfully, pretty minimal. And that seems largely down to some really crucial proactive steps.
Yes, this is a really key part of the story. The sources are clear. This wasn't, totally out of the blue. Scientists had been watching the mountain. They'd actually predicted a likely disaster because things were getting unstable up there.
So they knew something might happen.
They did. And based on that prediction, the authorities took some pretty extraordinary measures. 10 days before the collapse, on May 19th, they evacuated the entire village, all 300 people.
The whole village. Wow.
The whole village. They even airlifted sheep and grazing cows out by helicopter to get them out of the danger zone.
That's incredible foresight. So the evacuation worked extremely well, but tragically, not quite perfectly.
Sadly, yeah, that's right. One person, a 64-year-old man, was reported missing after the collapse. The search had to be suspended because the conditions down there are just still too dangerous.
Oh, that's terrible.
Yeah, as one source put it, everyone was evacuated except perhaps this one person. It's just a heartbreaking detail when you think about how many lives were saved.
Yeah. And the mayor's quote, I think it was in the NPR piece, really captures that feeling, losing a whole community like that.
It's a really powerful and resilient message. The mayor, Matthias Bellwald, he's quoted saying, "We lost our village, but not our lives." And he also talked about solidarity, determination to rebuild. He said, we are going to be in solidarity and rebuild. Everything is possible. It really speaks to that deep connection people have to their home, even after something this devastating.
Absolutely. Okay, so let's get into the why. Why did this happen now? The sources dig into the geology, but they also highlight something kind of unusual about the Birch Glacier itself.
They do. And this is interesting. The Birch Glacier was actually unique in that area because unlike most glaciers in the Alps, which are, shrinking, receding.
Right, that's what you normally hear.
Exactly. This one had actually been advancing for the past decade or so.
Huh. Why was it pushing forward when others were melting back?
Well, the source explains it was basically being fed from above. Rock face higher up the mountain was breaking off and piling onto the glacier. So that added boulders, weight, pressure, and that forced the ice to move forward to advance.
Okay, so falling rocks were adding weight, making the glacier advance.
Yeah.
But why the increase in rock falls in the first place? Is that where the sort of bigger picture comes in?
Precisely. This is where the sources make a direct link to climate change. The increase in falling rock, they attribute it to melting permafrost.
Right, the frozen ground.
Yeah, think of it like ice acting as glue, holding the mountain rock together in these cold regions. As the climate warms and that permafrost melts, the glue disappears and the rock becomes much more unstable.
And they even gave a specific number for how much that permafrost is warmed.
Yes, the geophysicist points out that permafrost right there in that area has warmed by at least 1 degree Celsius just in the last 10 to 15 years.
Wow, 1 degree makes that much difference.
Apparently so. As that underlying ice melts, the rock is just more prone to fracturing and eventually collapsing.
So, melting permafrost makes the rock unstable, leading to rock falls, adding weight to the glacier. But the geophysicist also talked about a kind of natural, ongoing process that makes places like the Alps unstable anyway.
Right. They describe the freeze-thaw cycle. It's basic erosion. Water seeps into tiny cracks in the rock, and then it freezes, expands, which widens the cracks. This happens over and over, season after season, making the rock brittle, unstable over time. And when you combine that with steep slopes and a lot of weight on top, what they call overburden, it just increases the likelihood of collapse. It's a fundamental geological process, shapes mountains over long time scales, happens frequently, geologically speaking.
But this specific event, this wasn't just a typical rock slide or something.
Oh, far from it. The sources really emphasize how extraordinary the scale was here. The Swiss environment minister was quoted saying, "What happened today is absolutely extraordinary."
Yeah.
And the high mountain geology specialist called it the catastrophic worst-case scenario, the worst we could have imagined. So yeah, while the underlying natural processes are always there, the scale here, maybe amplified by things like the rapid permafrost melt, was just immense and devastating.
So, okay, scientists saw the increasing rock falls. They knew something was likely. But the sources suggest the total collapse of the entire glacier wasn't exactly what they predicted. Is that right?
That seems to be the nuance, yes. They knew there was significant risk from the mountain slope. And apparently, an animation made just days before the event did correctly identify that the Birch Glacier could collapse.
Right.
And there were definitely warning signs, isolated rock falls happening, visible cracks appearing on the glacier, and significant movement detected in the days right before it went.
So the signs were there.
The signs were there. But the sheer scale of it, the near complete sudden detachment and collapse of the whole glacier, that seems to have maybe exceeded what they thought was the most probable scenario, even with all those warnings.
Let's talk about the raw power of this thing. I mean, beyond just the visuals, which are horrifying, there's a scientific measurement that really hammers home the force involved.
Absolutely. That video footage, the dramatic cloud that some people even compared to an atomic bomb cloud,
Yeah.
that gives you a sense. But the landslide itself, just moving that unbelievable volume of material so quickly down the mountain, it actually registered seismically. It showed up as a magnitude 3.1 earthquake.
A 3.1 earthquake from a landslide.
That's wild. So was the ground actually shaking like a tectonic event?
Not quite in the same way, no. The geophysicist clarifies this wasn't, a fault line slipping. That 3.1 reading, it's a measure of the seismic energy released by all that material, those millions of tons impacting the ground and moving so fast.
Wow.
It's a direct measure of the kinetic power that was unleashed. Just incredible force.
It really underscores that phrase the Swiss environment minister used. Nature is stronger than human beings.
It's definitely a humbling reminder of the immense forces at work in these mountain environments. And, while this event itself was extraordinary, maybe the most concerning thing the sources raise is that, well, the biggest risk might actually still be to come.
Wait, there's more danger. After all that.
That's the chilling prospect one of the sources highlights. See, the Birch Glacier collapse, as enormous as it was, it happened below and sort of underneath a much, much larger section of the mountain slope, the main mountain flank.
Okay. And that main flank is also showing significant signs of being unstable. And it hasn't collapsed yet.
So the really big piece is still hanging up there.
That is the major concern now, yes. The sources stress that this main mountain flank is significantly larger and also much denser than the mix of ice and rock that came down with the glacier.
And what's the prediction for this bigger flank? Are they expecting it to go too?
The geophysicist describes the signs, the evidence they're seeing now, as looking very imminent for collapse.
Imminent. That's concerning.
Yeah.
And if that collapses, what would happen?
Well, the potential impact is even greater. A collapse on that scale could trigger a seismic event significantly stronger than the 3.1 we just talked about from the glacier.
Right.
And of course, it would send an even larger volume of rock debris down into the valley, likely engulfing anything left standing in Blatten, and maybe having even wider impacts down valley.
What makes them think it's so unstable and imminent? What's the evidence?
The source points to time-lapse videos. Even days before the glacier collapsed, these videos showed this main mountainside was already actively fracturing and slipping.
Okay.
But crucially, the rate of that slip, how fast it's moving, has apparently accelerated since the glacier collapsed, especially now that the glacier isn't there anymore to provide any kind of, structural support at the base of that flank.
So the first collapse made the second, bigger one more likely.
It seems that way. It's a highly unstable situation that's been made worse by the event that just happened.
It helps to put this all in context geographically. The sources use things like Google Earth views, right?
Yes, exactly. And if you visualize the area, you can see Blatten down in the valley, and then you see this massive mountain flank still looming above it. It really helps you understand the scale and how it's just one part of this larger mountain system in that really steep terrain of the southern Swiss Alps.
And the before and after images must be just stark.
Oh, they are. Comparing pictures or graphics of the valley floor before the collapse and after, you just see this hugely expanded scree slope, the whole area covered by debris. It gives you a really tangible sense of how much the landscape changed in an instant.
So ultimately, while this was, an absolutely extraordinary event, the sources also kind of grounded back in the reality of natural geological processes just doing their thing.
Exactly. The freeze-thaw erosion we talked about, the steep slopes, gravity itself, these are the fundamental forces that are always shaping mountain environments. What happened here seems to be a combination of those natural processes, but happening on a massive scale, and amplified, maybe dramatically, by factors like the warming permafrost and the unique situation with the Birch Glacier advancing.
Right.
It's a natural disaster, absolutely, but one where it seems human influence on the climate likely played a significant, maybe accelerating role in triggering this specific catastrophic outcome for the village below.
So summing up this deep dive then, we've unpacked this really catastrophic collapse of the Birch Glacier above Blatten. It was a powerful, destructive event driven by that intersection of basic geology freeze-thaw, gravity, but amplified significantly by the warming climate, melting permafrost, destabilizing the rock.
Yeah, and we've seen the remarkable outcome of that timely evacuation, saving potentially hundreds of lives, even though the village itself was tragically lost, buried under the debris. And we've highlighted this really deeply concerning prospect of an even larger collapse, possibly still to come from that adjacent mountain flank, which remains unstable.
The scale, the power were just immense, registering seismically, burying the valley under millions of cubic meters of rock and ice. It's a story of destruction, yes, but also resilience and definitely ongoing risk.
It really leaves you with a lot to think about, doesn't it? About how dynamic our planet really is.
It certainly does. And maybe here's a final thought to leave you, the listener, with. Consider how these slow, often invisible forces, like the gradual warming of permafrost, driven by climate change, how they can quietly interact with the fundamental geological processes that have shaped mountains for millennia. These interactions can build up pressure, almost unnoticed, until suddenly they trigger catastrophic rapid events like the one in Blatten. What does this tell us about the complex ways climate change might already be influencing Earth's geology? And what could this mean for other communities living in similar, naturally dynamic environments all around the world?